Hi guys, welcome to Learn Electronics Repair. I have another product from FNIRSI here. They've sent me quite a few interesting things recently. And this one is the DSO-TC3. So this is what they call a 3-in-1 oscilloscope. I think the easiest way to explain what this product is to you is to actually show you the web page. So here it is, the DSO-TC3. Digital oscilloscope, transistor tester, function signal generator, 3-in-1 multifunction electronic component tester. That's a bit of a mouthful, but I think this could be really quite an interesting product. So we have two packages. The only difference between the two is this one includes the oscilloscope probe and this one doesn't. And to be quite honest, the difference in price, €5.80, I would suggest that this is the one to buy. And we can see it's saying it basically meets the needs of all component detectors. It's a signal generator, sine, square, pulse, triangle, ramp, and DC. Actually, that's DC output voltage. Battery powered. This is the component tester feature of this tester. Bracket. Capacitance, resistance, inductance detection. Triode, this is a transistor, bipolar transistor detection, diodes, mosfets, and then the digital oscilloscope. So this is a 500 kilohertz oscilloscope. This is okay for power supply repair and audio repair. It's not a very fast one, but for a low cost item, for use in field, it may well be useful, depending on what, of course, you want to work on. Information about the waveforms up to 100 kilohertz. Toolbox. Automatically analyze NEC protocol infrared codes. Okay. Continuity tester. 0 to 40 volt input voltage measurement. Pulse width modulation output. 0 to 32 volt zener diode measurement. And then we have temperature sensor measurement, temperature humidity sensor, etc. And this is the actual specification. So that's what we have. I have this package, so we're going to take a look at this one. And we have a quick look at some of the reviews. So this has 95% 5-star reviews. People seem very happy with this. So let's see what we think. Okay guys, so you can see what we have here. My initial thoughts on this, and I haven't tried it yet, is this may well suit two types of people. I think for electronics hobbies, people who are learning electronics, this could be a very handy device because you get a lot of functions for your money. And I think for power supply repair, audio repair, on-site use, this could also be rather useful. So let's see what's in the box. And here we have it. Okay, so we have the link to the firmware and manual, so the firmware can be updated on this. We have a standard test lead. We have some little clips. I think these are probably very useful for testing components with the component tester. We have one manual. A little bit of information. Obvious stuff. Discharge capacitors before you're testing them. Don't use it while it's charging. Does mention about it having no reverse connection protection, okay. It mentions here that it will measure voltage up to 40 volts, but with the oscilloscope probe, it'll actually measure to 400 because it's a 10 times probe switchable. So this can actually work up to 400 volts, which is much more useful for repair work. Okay, so a little bit of useful information. The little badge thing that we always get with these. And this is the device. This is quite small, fits neatly in my hand, okay. I'll remove the little screen protector. Don't need that. Okay, and there we have it. See if this is powered up. Oh yes, it has a battery already charged in it. scope, generator, tools, M tester. Yeah, so those are your options. Oscilloscope, signal generator, tools, and component tester. Okay, let's have a quick look at the scope probe that came with it. So here is a scope probe. Looks very much like a standard one, quite a decent one, I think. This is a normal BNC, and then it has this is the P6100, which it has a 100 megahertz probe, although obviously the oscilloscope can't measure up to that. Useful to use it if you have a bench oscilloscope as well, that's for sure. And the specification sheet. So this is basically a standard oscilloscope probe, and it comes with this little adapter. So this fits onto the BNC, okay, and then this plugs into the tester. We also have a USB-C charging lead, but we don't actually have a supplied charger. Let's power the TC3 on, see if it comes with a charged battery. Yes, it looks like it does. And we have a main screen, oscilloscope, generator, tools, and M tester. This must be the component tester. So we have those four options. We have an OK and menu button. Okay, and we're now in the oscilloscope. So normally, guys, I tend to just jump in with these things and make a review, figure out how easy these things are to use, how intuitive they are. But in this case, because this device has a lot of features and it's not something I've specifically used before or anything similar to this one, I will actually read through the manual first, because I think in this case I can probably make a better review of the product if I do that. To use a scope actually is quite easy. So we have the left, right, up and down, and if we just press the buttons it goes to the various options. So at the moment there's a little blue cursor there if you like, so this can set the vertical position. I'll just put it to the center, 0 in the center if you like. Okay, and there we have the voltage. So again we can just adjust this up or down. And let's actually connect a signal as well while we're doing this. So I'll connect this to my signal generator, which at the moment is set to 100 kilohertz. And we do see a waveform there. It's showing fairly close to 100 kilohertz, the frequency. Now you can see as I adjust the voltage or adjust the amplitude of the waveform. Okay. This position sets the probe sensitivity of either 1 times or 10 times. I have the scope probe set to 10 times, and I suggest if you have one of these you leave the scope probe on 10 times. You can then measure up to 400 volts. If it's on 1 times you have a 40 volt limit, and you may exceed that on things like audio amplifiers, power supply repair. So I would personally just set it to 10 and leave it on 10. The only exception to that probably is if you want to look at some very low amplitude waveforms, and then you could set it to 1 times. The amplitude setting goes down to 100 millivolts. If I put my scope probe onto times 1 and we change this to 1, it goes down to 10 millivolts. But normally I think 100 millivolts is probably enough. I'll put my probe back to 10 times and I'll set this back to 10. Okay. One of these two cursors is the trigger and the other one sets the position of the waveform. I think this one is the trigger. We can try, we'll find out. And you see we just go through the various options, and I think this one sets the waveform position. Yeah, it's moving the waveform. Okay. We also have some other useful options on here. So for example, we have trigger of auto, normal, single. I'll leave that auto. This option in blue allows you to set rising or falling edge for the trigger. This arrow, I'm pretty sure, sets the trigger point. We'll have a little play with it in a minute with the waveform. In fact, let's do that now, actually. So we'll connect my signal generator, okay? We'll come back to that trigger in a moment. We have DC or AC. Okay. This is the time base, again up or down. Okay. 1 microsecond is the fastest. Okay. And back to the setting for the probe type. This has an auto feature, so if we just connect a signal, I'll just change some parameters so we don't get a good display. It's too big, it's off the screen. If we hit auto, it will actually set it up for us. But we can also set this manually, so that's useful. We have both the option to manually set the display, auto set the display. I quite like that, actually. As with many of these oscilloscopes, I think we can actually go above 500 kilohertz. I usually find they will at least display a waveform up to a megahertz or so. Let's try it. Well, that's 400 kilohertz. I've noticed the display does wander around a little bit. What's this one do? Stop. Oh, okay, so we can actually run or stop with this button. And it gives a different kilohertz. So it's kind of wandering around between 395 and 411, okay? So it's not exactly stable, but it gives you an indication, I will say, of the frequency. Okay, we're back onto run again. Hold button. That removes the actual readout, so you've just got the waveform now. Long press puts it back on. Okay, that's quite handy. Okay, so let's try the trigger, which I'm pretty sure is, we go the other way, I think, the quickest. Yeah, over the top, so that's in blue at the side there. And then we'll move this up or down. So if this is the trigger, which I'm fairly confident it is, this sets the point in the waveform at which the oscilloscope triggers. So as long as the trigger point is within the waveform, it should stay stable. I'm triggering near to the top of the waveform now. If I go outside of the waveform, it should just lose the trigger. Yeah, there it goes. Because I've told it to trigger at this voltage, which is outside of the waveform. Quick, bring it back in, it's locking. So the trigger's working quite well. I'm going to take the frequency up above that and just want to see what will happen. Well, that's at 500 kilohertz, which is the stated bandwidth of the device. Again, notice the frequency display is wandering around a little bit. Let me go higher than that. Okay, I'm now at 900 kilohertz. The trigger is now outside of the waveform, but it will trigger and it will display it. So again, with that instability, it's like 900 and something. I'm going to go higher than that. Well, that now is at 1 megahertz, and I think that instability gets worse as you go outside of the range of the device. But bear in mind, this is really specified at 500 kilohertz. But it will at least show you that there is a sine wave there, which often for repair work, at least that's all you really want to know. I'm interested to see how far I can take this before we actually lose the display. So I'm going to move the trigger point down towards the middle. And I'm going to increase the frequency in megahertz at a time. Well, that's on 2 meg, but the frequency display still says 1 meg. So at that point, it doesn't display a frequency anymore, anything like. We can see there's a signal there, but that's as much as we'll say. So I think the oscilloscope is fairly run-of-the-mill for a cheap oscilloscope. For hobbyist work, I think this is absolutely fine. If you're learning the electronics and you want to learn about waveforms and pulse width modulation, and bear in mind this is a cheap instrument, I would say it's fine for that, but not for advanced use. I'd be happy to use this on a power supply to see if it is oscillating. Even on a fast power supply, you might find the pulse width modulator is running into 600-700 kilohertz, but this will at least show you that the pulse width modulator is running. If repair work, that's fine. Just to be certain, guys, that my signal generator was not playing up, I've actually connected it to my other handheld scope. This is another FNIRSI IC15 that I reviewed recently. And you can see it's changing from 499, 500, 501. It's mostly stable on 500. So that's the same signal, same amplitude from the same signal generator. So it was definitely the display on the oscilloscope on the 3-in-1 that was wandering around in frequency. Okay, let's have a look at some more features of the TC3. So we'll press this button. I think this takes us into the menu. Yeah. Okay, so we can switch the logo on or off. We have language, the volume of the bleep. A little louder. Brightness, factory settings, about. So you can actually upload new firmware to this as it becomes available. That will bring us out. That's the out arrow. So we're back to the main menu. This is a signal generator. Let's have a little play with this. I think the best way to test this would be for me to take another oscilloscope and let's look at the output of it. Okay, here is my miniware scope. So I'll connect it to the signal generator output of the FNIRSI. And then let's have a look. So with this one, I'm just going to change the time base a little bit. Okay, and we can see a 1 kilohertz sine wave coming out of the FNIRSI. I've changed the frequency now to 10 kilohertz. The maximum amplitude is 3.3. So the way this works, you get the little white cursor onto whichever digit you want, and then up or down. So that's how you actually change the frequency. The amplitude, we just effectively press these until there's no white cursor. We go down one and then right or left whichever digit. So for example, I can set it back to 3 volts, 2.9, back to the maximum 3.3. In the meantime, my oscilloscope's actually gone to sleep, but that's normal. Okay, so that's how we set the frequency. On my oscilloscope now, I can just alter the time base, so there we have it. And it's saying it is 9.1 kilohertz. I actually have this set to 9. I'm going to set it to 10 again. Sideways arrow to get this on once again. And then we can press up, change 9 to 10. It's now 10 kilohertz. This is saying 10 kilohertz. I've now set it to 1, so it's a very low frequency. If you do that, if you hold the button here, it effectively goes to 10 and to the next digit. So it's very easy actually to get it back to 10. There we are, 10 kilohertz. Okay. So basically, this goes to frequency, the digits. With nothing selected in there, down takes you to the amplitude. With nothing selected, down takes you back to the frequency. Left takes you with nothing highlighted there back into the waveform selection, and now we can change it. Square wave, okay? Again, we can set frequency if we like. Come back out. Pulse. This now effectively is a square wave, but we can set the duty cycle. Let's try that. So right arrow into here. Yep, this is going to the various digits. Wait till nothing is highlighted. There, down, duty cycle. And now we can change this. So look, I'm altering the duty cycle. More off time. More on time. Okay. Press run so nothing's highlighted again. Come back to this side and now we can try triangle. Ramp. Oh, I see. That alters the shape of it. I thought a ramp should be sort of like that. Like what I would call a sawtooth. Yeah. Okay. I'm getting used to the way this works now. So the function generator definitely works quite well. And the last one is DC. which allows us to output a voltage. My oscilloscope is on AC at the moment, so I'll just change the setting so we can see this working. There. DC. And now we can output a voltage. So it looks like the highest voltage is 3.3. And again, we can highlight a digit 2.3, 1.3, 0.3. Okay, so we can put a steady voltage out. The more I'm playing around with this, I'm coming to the opinion that this is best suited to the hobbyist. I mean, that is useful in as much as, like, if you want to try to enable a chip or something when you're doing the repair, and you could do that sort of work with it. But I think this is kind of like designed with the hobbyist in mind, somebody who's learning electronics, your own little electronics lab, and I can see actually it is rather ideally suited to that. Okay, so we've had to play with the signal generator. Now let's try the next feature. So this is the toolkit. What do we have in here? Well, it looks like we have some various options here. I think we need to move this to the in socket. Okay. Tongue one, I'm not quite sure what that is. Is that a continuity test? Let's have a look. No. I'll have to look that one up. Okay, guys, I had a quick look. I kind of figured it just by thinking it through, actually. So this input here says in 0 to 40 volts. I think that's for voltage measurement. This thing, tongue one, appears to be continuity. And I've just put 2 leads into the component tester on 1 and 2. And I now have a continuity test, okay? Let's try a low value resistor. So this is a 0.22 ohm. This is, if you remember the last multimeter I reviewed, it thought they were short. So what this thinks of them. Okay. Well, actually, I think they're short as well. Interestingly, that's 2 out of 2. My multimeter reads these and says they're resistors. Somebody complained last time that I tested that on my Fluke and they said it wasn't fair. So we go to ohms range instead. And it says it's a resistor, as opposed to what it says is a short. It wasn't calibrated well, so 0.3. 0.5, so that knows it is a 0.2 ohm resistor. Okay, use something cheaper just to satisfy some viewers. It's okay, guys, though. You know, you think I'm doing something unfairly, we'll do it a different way. So that is a continuity tester. Let me see what the maximum resistance would be that it would read. Well, I had a quick check and it reads up to 50 ohms or so and bleeps. I tried a 1K, it did read it but didn't bleep. But this also has a resistance range anyway, which apparently goes well into the mega ohms on the component tester. So we'll try that instead. The voltage input, this one is for measuring up to 40 volts. That is what the other input socket is for on top of the unit, this one. I can just attach my bench power supply. Let's have a quick look. Okay, I have one of my bench power supplies set to 5 volts. Let's just stick it onto here. It says that the red is the positive, but it does mention that it's not reverse polarity protected. And it's saying 5.015. I mean, I don't know how accurate this is, but that seems good enough to me. $12 volts. Let's just go up to the maximum. 31.8. That's saying 31.9, 31.857 to 1 decimal place. That is good enough. So that facility seems to work okay. DS-18B20. This is some sort of temperature sensor. I don't have any, so I can't test it. The same with this one. And infrared decode. This I'd like to have a little play with. It does mention in the manual this will decode NEC protocol. I don't know if that's like a generic thing. I don't know anything much about infrared remotes apart from you point them at things and they do things, but we can have a look. Well, that doesn't do anything with that remote. Let's try another one. The remote's working. Okay, so that doesn't seem to do anything with these remotes, but I'm not sure whether it should do, to be honest. We have a calibration mode, so it's saying please short probe. I think from what it was just saying in the description, we put the wires in 1, 2, 3 and we short them. Okay. Yeah, that seems to be the case. I'm just shorting all the wires together. Isolate the probe. Isolate the probe. Yeah, okay. And then it will continue. And that has calibrated the unit. I've just tried a different remote and this does work. Okay, so it appears to be able to read the protocol of some remotes. This is off one of the high brightness outdoor TV monitors we have here. So that function definitely works. Let's now look at the component tester. Oh no damaged part, of course. Let's connect a few things. This is a high value resistor, 4.7 meg. Yeah, 4.7 meg, it's happy enough with that. Let's try a low value resistor. This is the 0.22, I'm not sure if it will read as low as this, but we can have a go. Well, yeah, it says it's a 0.2 ohm resistor or a 0.02 millihenry coil. Let's try an inductor or 2 or 5. I have a few inductors here. I'm not sure what the value of this one is. Let's see what it tells us. Yeah, 0.4 millihenries, 0.04 millihenries. And the other ones we can try. Quite chunky one. So you have to kind of know if it's a resistor or an inductor, but it will read it. Yeah, okay. It has the same resistance but a different inductance. Let's try some capacitors. 820 microfarad, low ESR capacitor. What does it think of this? Okay. What's thinking about it? Yeah, it's quite, and it gives the ESR as well. Okay, that's quite nice. Try another capacitor. This is a larger one, it's a 2200. Go between different wires this time. I don't think it matters. Okay. Yeah, with the ESR 1990, that's quite accurate. I mean, considering these capacitors are probably with 20% tolerance anyway. I quite like the way this comes with the little leads and where you can insert the transistors and things into the holes directly. I think that's quite handy. Try this. So this is transistor, NPN or PNP. I'm not sure, but we're going to find out. Okay, gives us the gain, the base voltage, the collector current, okay, PNP. Of course, we should also try an NPN. Yeah, NPN, gain, base voltage, collector current. Let's try a triac, see what it thinks of that. Yeah, fine. JFET or junction FET, a bit more of an unusual component. Yeah. Let's try a few diodes. This is a 1N4148, very common silicon diode. Yeah, that's fine. This is a common cathode, double diode. Let's try this. It doesn't matter which wire you put where. Okay, double diode. It's 0.5 volts on each one, so that's not a Schottky diode. Schottky diode would read about 0.15 or 0.2. This should be a Schottky diode, just a single one. Let's try this. So any two wires. Okay. Yeah, Schottky, 0.21, that's fine. We can try a couple of LEDs as well. So normally component analyzers will say these are diodes, which they are. They have a higher forward voltage drop than a normal diode. And the voltage drop depends very much on the color. So usually they would flash. Let's try it. Yeah, it's flashing red. It's obviously a red one. And that's giving us 1.92 volts. Fine. Try another one. This is a blue one. Higher voltage drop, 2.75. This is a white one, which actually are ultraviolet LEDs with a fluorescent coating, basically. That's how they get the white. Yeah, flashing white. 2.73 volts, very similar to the blue, that's normal. And we can try a bicolor LED. So for this we need all three wires. Okay. Yeah, it's flashing different colours. Yeah, red and a green one. Different voltage drops because of the different colours. And now let's try some zener diodes. So this apparently will test zener diodes. We have to use these connections, KA, either of the A's, doesn't matter, there's two of them. That's making this easier to actually insert the component into the tester. I'm going to use the clips. Okay, let's try a zener. So it says it will test up to 32 volts. I'm sure I can find one close to that. This is a 30 volt zener or something close to that. Let's have a look. Yeah, 29.5 volt zener, red to the cathode, so that's fine. So if this will test zener diodes, it may test a few things that are not really mentioned by FNIRSI in the documentation. I'm interested to try some high-powered LEDs. This is a 30 watt RGB LED. Let's have a look what it thinks of this. So you can't test this with a multimeter. If we just try, so we'll take a multimeter on diode test range and let's see what we have. So we're on diode range, open circuit, open, open, all the way around. So this just reads open. Okay. Let's see what the TC3 thinks of it. So we'll connect two wires. Okay. Well, it lights up to start off with. It's lighting it up green. So we know it's a good LED. Let's see what it says. Well, it thinks it's a 22 volt zener because that's the working voltage of the LED. This is blue. 25.7. So it thinks these zener diodes, but it will test them. That's nice. Okay, 17.4. The red is always the lower. So if we'll test a 30 watt LED, how about a 90 watt? This is a 90 watt LED, RGB again. So 3 times 30 watt. Let's have a look. So this is probably red. Yeah, this is red, they're all lighting up. Yeah, 17 volts, green. Yeah. Blue. Yeah. So we can test RGB LEDs up at least a 30 watt. That's the highest power one I have. But I'm thinking now, if this will test LEDs on the zener mode, it should test LED strips as well, actually. Let's try it. So white will be the common. It's lit up. 5.7 volts. I think it's a 5 volt strip, actually. Try that one. That's lit up. You may not see it. You can probably see on now red. That's lit up. Blue. Okay. It's lit up again. So we can test LED strips with this. For FNIRSI, I'm finding some extra uses for your little meter. Maybe you want to add them to the documentation. It did it very well. Anything else we can test with this? Well, one thing that comes to my mind is TL431. So if we connect the two outer terminals together and then we connect separately to the other central terminal, if this is good, it should read 2.5 volts as a zener. I would think it'll probably say zener 2.5. Let's see what it thinks. Yeah, 2.6 volts. So that tests TL431. That's quite nice as well. How about diac? This is a DB3 diac. So this is kind of like a bidirectional zener. So if we connect it one way round, it'll probably say it's a zener, I'm guessing. Let's see. So it's saying it's a 32 volt zener. Now if I reverse this, so we have effectively the cathode to the red. So if I put this the other way round, I'm expecting it will also say it's a zener the other way, which tells it's a diac. Yeah. So with a change of firmware, we would probably recognise that as a diac actually, so that's something else that could possibly be done with this. And another thing that comes to mind, I don't know exactly, but I think with a change of firmware again, this could probably test voltage regulators. 7805, 7812, 15 and so on. So those are maybe some suggestions. I know this is upgradable with firmware. I do not have the knowledge to do that sort of thing, but I do have the knowledge to think of a few good ideas. Okay, so now I think we need to sum up. To sum up then, I think the 3-in-1 represents excellent value for money. I do think this is aimed particularly at the hobbyist. That seems to be the market it well suits, and if you were setting up an electronics lab on the cheap, this does a lot of things in one unit. It's small, convenient. Add to this a multimeter and a bench power supply, and probably for a little over €100 in total, you've got a very good setup to get started. I believe I've shown that the oscilloscope is the weakest part of this, so the display wasn't stable. I did compare that with another FNIRSI scope just to be sure. I was using the same setup, same cable, same signal generator, everything the same, and that was stable. So that seems to be the weakest point with this. The strongest point, I think, is the component analyzer, and that does a lot more than most component analyzers, especially the ability to test things like TL431 I was doing, high wattage LEDs, and obviously zener diodes up to 32 volts. I think that's really good, and I just really did like that. The voltage measurement to 40 volts, fair enough. Personally, I would use a multimeter for that facility, but if you're on a little bench and you want to measure current on your multimeter and voltage on this, I can see the use of it. The remote control feature, I don't really need that, but I rather liked it. It was something a little bit different. In fact, this does do a few different things I haven't seen before, really. So all in all, I will definitely give this a thumbs up. Bear in mind what I've said about the oscilloscope. If you're the sort of person who is learning electronics and you want to start off with something inexpensive that will get you a long way, I think this is ideal for that. The signal generator was fine. It was stable. It didn't go to particularly high frequencies, but it did do a lot. We had the various ramp waveforms, triangle, sine, square. We had pulse width modulation, different frequencies, different duty cycles. Again, for experimentation, I think you can do a lot with that. So really, if you are a beginner who's learning electronics as a hobby, I think this is ideal for you. For repair work, it's something nice to put in your tool bag to take on site. It does do quite a bit, but I think on the repair bench, there are better options if you have the money to buy them, I will say, okay? So that's my honest opinion of it. I do like the product, especially the features I've already mentioned, and I'd be very interested to hear what you guys think in the comments below. Okay, hope you enjoyed that one, and I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.